Hello everyone. So today we are doing this first question of IE Irodov and it's of electrostatics. So the question says calculate the ratio of the electrostatic to gravitational interaction forces between two electrons and two protons separately. At what value of specific charge Q by m of a particle would these forces become equal in the case of interaction of identical particles? So first let's do these, I guess, part 1 and part 2. So part 1 says calculate the ratio of electrostatic to gravitational interaction forces. So let's say the electrostatic forces Fg and gravitational forces Fg. So the electrostatic force for two electrons would be a repulsive force and it is given by K Q1 Q2 by R squared equals the value of K is 9 into 10 to the power 9 into Q is charge of electron, that is 1.6 into 10 to the power minus 90, and again so this will become square upon R square. I'm leaving it like this because the force of gravitation also has R square beneath it, so that will cancel this out. Yeah. Now let's calculate the force of gravitation. That is 3 m1 m2 by r squared. That is equals to um, 6.67 into 10 to the power minus 11. And m1 is mass of electron, and mass of electron is 9.1 into 10 to the power minus 31 kg. And we have that 2 times, so it is squared upon distance between them squared. So we have to calculate the ratio. K upon this part. Now this is a pure calculation, but still, I guess I'll calculate this. So 16 squared is 256, so 2.56 into 10 to the power 9 minus 10 to the power 38 upon 6.67 into 9 square 81, and this will be 10 to the power minus 11 minus 62. I guess I'll use calculator for so let's do the same thing for our two protons now. Second part, we have to calculate the ratio between force of electrostatic repulsion and gravitation. So the top part will be same, that is which we calculate here 23.04 into 10 to the power minus 29 kqq upon r square, and this will be g 6.67 into 10 to the power minus 11 m1 m2. Now mass of proton, it is 1.6 into 10 to the power minus 27 kilograms, and this will be squared. So how much is this? Sorry, 6.67 into 2.56, and this will be 10 to the power minus 29 upon 10 to the power minus 11 and minus 54, and this is 10 to the power minus 29 plus 55. This will be this much into 10 to the power uh, 36. Yeah. Now we have the third part, which says at what value of specific charge of a particle would forces would these forces become equal? They are talking about the electrostatic and gravitational force. Okay, for identical particles. So they're saying there are two identical particles. There is electrostatic repulsion, or you can say attraction, and gravitational. This is force of gravitation. This is electrostatic repulsion. When will these two be equal? So they have said these are identical. They have same charge and they have same mass. We have to equate K, Q, Q by R squared to G M M by R squared. This cancels out. Now we have Q square into K equals G into M square. Or do we have to calculate Q by M ratio? So Q square by M square equals G by K. So this equals under root 6.67 into 10 to the power minus 11 upon 9 into 10 to the power 9. This equals 10 to the power minus 20. So 10 to the power minus 10 बाहर आ जाएगा, and we get 0.86. This is 8.6 into 10 to the power minus 11.